Welcome to UVU CS3060 Lecture 0.1, where I discuss public-private key authentication and how you can get set up to use such on the server. Now, traditional authentication is done with some private information, a password that the user has memorized. That password is fed into the client machine, and the client machine negotiates with the server or service with that particular key to determine if the user is authorized to use that particular service. The way this is done is the particular password is hashed, and that hash is compared on the server to determine whether or not they're equal, and if they are equal, then the user is allowed. There are several problems with this. The first is the password. We're humans. As humans, these passwords need to be easy to remember. Long, complicated series of characters tend to be very difficult to remember. And so we do things such as mnemonics, or we just simply take the name of our favorite pet, or put our birth date in there, which is horribly insecure because those things can be found fairly easily by anybody determined enough to access our account. So even though these need to be easy to remember and they're less secure, we still have the problem that even the easy to remember stuff can be easily forgotten. Also, this private information isn't the only problem. The public information, this is a hash that's kept on the server, it's not meant to leave the server, but very frequently this information gets out in the wild, is exposed to the internet. And because your password is usually very easy to remember, these things can be guessed using special software and something called a dictionary attack to guess your password, and then everything's wide open, especially if you reuse passwords across different services. So we can't trust the security of these servers to keep these particular password hashes safe. So what do we do? Well, the answer to this is public-private key authentication. So we start with generating a private key and a public key. And these go hand in hand. In fact, the private key actually contains information related to the public key, but not the other direction. Data in the public key cannot recover or expose anything that's in the private key. Now, the way public-private key works is whoever has the public key can encrypt data with that public key, but that data cannot be decrypted unless it is decrypted with the private key, meaning that anybody can have this public key, and if a server encrypts data using the public key, no other server, even if they have the same public key, will be able to decrypt that data. Only systems with the private key can decrypt it. These private keys tend to be very long strings of random data, so it's not easy to memorize. It's not easy to find. You can't use dictionary attacks on it. They are nearly impossible to guess. You can also, with most private keys, secure it even further by adding a password to the private key. If you add a password to the private key, then before this private key can decrypt anything, the actual password for the private key needs to be used. It's an extra layer of security. Now, the secret here is the public key can go anywhere. It can be put on servers. It can be put on GitHub. Almost anything can have a public key, but the private key must be kept secret and safe on your systems. You should be the only one who accesses it. It should not be allowed to be exposed on GitHub or copied to servers or emailed. Do not reveal your private key, because then you've allowed access to all services that may have a public key. The great thing about this whole system is, even if the server is hacked and the public key is exposed, all anybody can do is encrypt data with that public key. They can't do anything such as break into other systems. Now, we're going to use some tools to be able to access the server. The first, if you're using Windows, you'll want to use something called PuTTY, and I've included a couple of links here that will also be in the lecture notes. So let's start with PuTTY. The PuTTY set of tools, we're going to use two programs. The first program we're going to use is called PuTTYgen. PuTTYgen is used to create a public-private key pair. So what you're going to do is when you start this PuTTYgen program, the first thing you're going to do is you're going to select the key type. In this case, we're going to select EDDSA and make sure that the ED25519 is selected. There are other key types here. RSA is actually fairly common, and it's available for backwards compatibility. I do not wish to use that for this server, but if you do send me an RSA key, I will add it to the server. But for our example, make sure you select EDDSA for your key. When you've selected that and click the Generate button, what will happen is this bar will come up and you'll be prompted, please generate some randomness by moving the mouse over the blank area. And so you'll just simply twirl the mouse around here and this status bar will come across and complete. It won't take very long. This is to generate enough random data so that a random prime number can be created that is not easy to guess. Once you've generated your key, you'll see first a public key that is shown at the top of the screen here. This actually will eventually end up on the server so that you can log in. This is the public key that the server will use to encrypt data that you will use to authenticate. There's a fingerprint, which is a shortened version of this key data, but it identifies this particular public-private key. Once you've generated a key, give it a reasonable name. Here we've named it Student Laptop Key. You can name it your name and then the system you're working on. Whatever works for you, so long as you can identify where this private key is used. Once you've gone ahead and entered a key comment, go ahead and also type in a passphrase. It is optional. You can actually leave the passphrase empty, but that's not a secure way to handle your key. Now, it doesn't have to be terribly complicated. It doesn't have to be long. Here, there's clearly a long password that's being used, and that's always secure, but you can put a short password in here. Just make sure you do password your private key. Once you've created the key, once you've generated the key and added a comment and a passphrase, then go ahead and save both the public key and the private key. The public key you will submit via Canvas to assignment 0, and the private key you will keep and you will use with your various programs. That was the Windows. On Linux and Mac, it's a little bit different. You'll open up a command line and you'll type this command, ssh-keygen-t ed25519-c, and then the descriptor for that particular key. Now, you will be prompted for a passphrase. You are always welcome to press enter. First, you'll actually be prompted for a path of where it's going to save that. Just press enter at step number 2 here. Type in a passphrase for step number 3, and then you will have generated a public-private key that will be stored at this location. The private key will be ID_ED25519, and the public will actually be the same name with .pub, and you can see that it's shown right here as well. Here's a signature key fingerprint. This is also a key fingerprint here called Random Art. used to easily identify a particular key fingerprint. So what will you submit for assignment 0? Well, for assignment 0, on Windows, you will take the file you saved as public key and submit that. Do not submit your private key. On Linux and Mac, you'll take the file that you generated in the .ssh directory, the pub file, and you'll submit that to Canvas. Do not submit the private key file. Now, once you've submitted this assignment, I will do a little bit of work on the server, adding your public key to your account, and then I will post a reply to the Canvas assignment 0, letting you know that this is done, and you can move on to logging in. So let's talk a little bit about that. On Windows, you'll use a program called PuTTY. PuTTY allows for an individual session to be configured. So we're going to go ahead and step through the configuration process. The first thing that we do is we come down here, we expand SSH, and then select Auth. SSH Auth allows us to browse for our private key. And wherever you saved that private key at, go ahead and browse for it and select it so that it fills this particular text entry box. Once you've put in your private key information, go ahead, click Session at the top of the categories list, and then enter some information for the session. You'll start with the server name, cs3060.tc.uvu.edu. Do remember that this is behind a firewall. You cannot access this from the internet without a VPN. So you need to, if you're doing this from home, you need to make sure that you have VPN configured on your system. And that is an exercise that you can go through with UVU technical support if necessary. But type in the server name, type in a session name, and click Save. Once you've completed these steps, you'll have a saved session here. All you need to do is double click that save session, and it's going to launch the PuTTY software and get you logging in. Now, the first time you do this, you'll actually get a dialog that pops up asking you to verify the server's host key. And what you're going to do is you're going to validate that this value here matches the value that I have here on the slide. This makes sure that you've got the correct server. Some PuTTY software will use this long hexadecimal value. Either one will work just fine as long as one of them matches. If they do, go ahead and click Accept. And then and it will go ahead and continue on to the next screen. Once you've gone ahead and accepted the host key, and remember, that's only done the first time you do this, it'll prompt you to log in. And you'll log in with a letter, prefix, and then your UVID. This will be provided to you in the comments of assignment 0. So when you check the response from assignment 0, you'll be given an ID. You will also be prompted for the passphrase of the private key if you added a password. Just go ahead and type that password for the private key in here, and it will finish the job for you and log you in. This is your login prompt. If you made it this far, you've done just fine. You are now on a Linux system, ready to be a Linux hacker. If you're a Linux or Mac person, you'll just simply SSH into the system using your ID at cs3060.tc.uvu.edu. It may ask you the first time to validate the fingerprint, and you can go ahead and validate it against this value here. But once you validate it, and it may prompt you for your password, you'll go ahead and log in, and once you get to this prompt, you are successfully into the system. This brings us to, so now you've gotten to the terminal, let's go ahead and talk about file transfer. Now, one thing to note is the Linux server is not your local system. You have a hard drive on your local system with files, and you have files on the remote server. And you need to have a way to move files from the remote server to your local system. On Windows, you'll use a program called WinSCP. Now, WinSCP allows you to use a private key. You just need to start by clicking the Advanced button. In the Advanced Sites setting, under SSH Authentication, you'll see the private key file path. All you need to do is browse for that private key, select it, and then click OK. And that will save that'll save that information for this particular session. So now you need to go ahead and type the information in for the session. The host name, which is cs3060.tc.uvu.edu, and your user ID. Do not fill in the password. This password is if the system you're logging into has a password. This is not the password for your private key. Once you've clicked save, you'll see a site in the session, and you can just simply double click on this. When you click save, it will change to edit. So you can edit this if necessary and change the advanced settings if you need to change the private key. When you double click on this, it is very likely going to prompt you to validate the server key signature. This again is the same data that you saw earlier. Once you validated that, clicking yes, it may ask you for the passphrase for your key. Go ahead and type your key passphrase here and click OK, and it will bring you up to this Explorer-like dialog, where you have your local file system, C, user, and so forth, and you also have your home directory on the server. You can change drives by selecting this drop-down box here, and it will allow you to change to different drives. You can refresh, you can create folders here. If you choose to download a file from the server, you would select the file, and this button would become active, and you just simply click download, and it would move the file into this directory. If you wanted to move a file from your local system into the server, you would select it and click upload. On Linux and Mac, in the console, you would just simply use the SCP program. SCP allows you to specify a source and a destination. Now, source and destination can either be a local file or a remote file. Local files, you'll just simply specify a path. So here's a local path here, source/p1/. This is a directory path that I want to store my file into. That's the destination. In my source parameter, I have a very long line of information here, but it can easily be broken down. You start with your UVID, @ and then the server host name, /, and then whatever path you want. Now, I didn't use / here. I just simply did source CS3060 p1.c using a relative path. In any case, this file will be copied from the server to my local directory here. And you can see that the file name here was copied successfully. It was very fast. This brings us to the end of Lecture 0.1, where I discuss public-private key cryptography, or authentication, and how to use it.